We're done. What did I leave off at? There we go. Okay, so we compile now. So the next big problem is getting this viewset UI to actually be fully correct. So when this runs, it generates the UI. It generates the UI list. We need to keep going a little bit and generate. Yeah, we need these things. And then when we hit that, that's when we're done. No, wait, no, that's not the thing that gets input either. So this converts our list into a UI control, which we want to do, and then we set the UI, then we're done. Because the next big thing that happens here is we get user input, and we're no longer entering into that loop. Anyone thinking music? I'm thinking music. In fact, more so than that, I'm going to be putting on Luigi.io, which I've been obsessed with recently. Not really obsessed with. I should put it this way. Obsessed with in the sense of it's a nice way to put music on, and interested in the sense that it's a neat thing to watch from time to time. If you're not familiar with it, I won't spoil the surprise, I suppose. But that's what I'll be listening to, is whatever's playing on that stream. Spelling is Luigi.io. For people watching on YouTube, that's Luigi.io. I mean, technically it's only somewhat interesting to me. It's like a evolution simulation type thing, genetic algorithm, I should say. But it's not a particularly impressive use of a genetic algorithm. As with most machine learning type things, it's pretty easy to imagine that it's just memorizing. It's memorizing much lower level information than you'd like to think. When you first encounter it. Like, it's essentially memorizing a series of moves and a compact network to state those moves, and not actually really learning concepts or methods of handling situations or anything like that. Yeah, it's based on the Mario thing. It's a different person, but they took the same open source code base, tweaked it up, and started that stream. far as I can tell, I mean, it uses a cool algorithm called NEAT, N-E-A-T. Um, the thing is, it's like you if you can't prove that your AI isn't just learning, memorizing a series of moves, then it's not particularly impressive AI anyway. And with that particular stream, it isn't. It's not like AlphaGo where there's no way they could have prepared for the games that the AI played. In Luigi.io and Mario, it's literally just we try some random moves. The moves that turned out to look the best, we keep them around and we try some variations on them. Standard standard evolution or genetic algorithm, except that the thing that you're producing at the end is just a compressed circuit basically for describing the series of moves that were memorized. Like you'd want to have it run with a different random seed or run on a different level every time or something to see if it was actually learning the game. If it was actually learning Super Mario Brothers, it would... Okay. So what they do on Luigi.io is they run a level until they beat it, and then they take the top specimen from the last generation, the one that actually beat the previous level, and they put it in with a bunch of small, small, fresh, like networks, right? So the population becomes a small population with just that one winner from the last level and a bunch of newly randomly generated nonsense players. And then they continue the algorithm. And usually the algorithm from the last level has learned a couple of basic concepts, like always run right, or almost always run right, jump if there's a pit, right? And some of them seem to have memorized how when they're underneath an enemy to jump, but they can't. The input to the AI doesn't tell it whether or not a platform is a block that will actually bounce up or a solid wall. So it'll often sit and try to hit an enemy a couple of times before moving on. So there's a few concepts that it has baked in there that don't seem to get lost from level to level. But for the most part, when you watch what it's struggling with, it's like it's struggling with the timing on a jump in a way that's like, that's not the hard part about that jump. Like, it can just randomly breeze past a bunch of really hard stunts and then choke on a really easy part because it hasn't memorized the moves to get past that part yet. Like right now, if you look at it, there's a big red bar on that stream. They show the mini map of the level, and there's a big red bar near the end. That's how far the AI has gotten so far. And if you look at that, it's like, why would the AI get caught there after being able to beat everything else? And it's because it just didn't memorize the move where it needed to jump right there. But it's kind of fun. It's kind of fun to put on for music, because it's usually video game music, which I appreciate. Alright, so part of the problem I'm seeing is that I'm storing these temporarily but not actually using them, and I think that's because they actually need to go in the state. Oh, I don't need those. Okay, I do need the count, but I actually don't need any of these things. I see how they're getting used now. Right, they get used to plug into these things down here. After this has passed, those three things, it actually becomes useless to keep those around because when we bake it into the control, the pointers change, and we're gonna clear out all that memory anyway. So those pointers would be useless. But it does raise in my mind the question: are we sure we don't use those later somewhere? Okay, hovered item doesn't come back up. Hot item doesn't come back up. Highlighted item does come back up. Yeah, how do we want to fix that? When someone presses new or tab, we're going to have to figure out what the highlighted item looks like. Oh, that's not going to be too hard. Yeah, okay. We can either do the iteration again, or once we're fully doing this as a list, we just look it up in the list what the actual answer is. Later, Ryan. Thanks for coming by. Okay, so this right here lays out the UI and updates the state as per this part of the loop before the input happens. Then what we want to do is we want to write a command for each of the input responses that can occur. So our commands include custom command sig, list mode, so this is one possibility, which is that we just want to close the UI. When we just want to close the UI, we'll call that quit. And all this has to do to quit is this. Guess I'll put the docs in with it. Okay, so there's our first thing we can do with input. We can also get, let's see, new line or tab, which will be list mode activate selected item custom doc a list mode command that activates the lists action on the highlighted item. Okay, in order to do that, what we're going to need to do is grab the view, get the view list state, and now what we need to do is we need to figure out from the index what the list item that we want to activate is called. So to do that, in this case, what we're going to have to do is just do the iteration that the UI would have had to do. And then once we have that, activate switch buffer app view buffer.buffer ID break. Alright, now we need to implement that right there. That'll be a quick helper up here. So this is responsible for actually doing the work that we used to do at the bottom of that yeah, at the bottom of this right here. What was that called? View seb buffer. I want to use that flag to prevent it from... I don't want that to kill the UI. I'm just going to kill the UI manually right here, which will be easier than having it send me a message. We don't need the ampersands anymore. Okay. So that goes, that ends the UI mode, and it sets the current buffer, and then breaks out of the command, and it's done. Great. So that's for those inputs. Key code. Key back does what? Okay, so this is list mode, backspace, text field, custom doc, a list mode command that backspace is one character from the text field. And then when it says needs full update, what that means is, well, let's see, a couple of things need to happen. This needs to get set to 0. view 0 scroll, and then finally we're going to call view set UI to switch buffer list. Update UI for switch buffer list. Now we want to get the state for that view. So we get the state, and then we can backspace the state's text field. We update the item index, we update the view's scroll, and then finally we update the view's UI. Cool. Sweet, okay. So there's backspace. Key up, down. Okay. There's no incremental search that does all buffers, no. I mean, there's the list search. And that goes across all buffers. But I assume you know about that, so I'm actually not sure what you're exactly getting at. Yeah, you can do Control-Shift-F, this sentence here. I mean, it won't find it because I don't have that anywhere, but I could do like global variables. Yeah, man, you got to be using the built-ins for it are Alt-Shift-F and Control-Shift-F on the English keyboard setup. Look for the commands list all locations, list all substring locations, case insensitive, list all substring locations, list all locations, case insensitive. All those combinations exist. I'm surprised you like 4coder if you didn't know about that. Wow. That's very surprising. I use that all the time. Another one that I like is bound to, while I'm giving you tips, is bound to list all locations of identifier, where you can just hover over some word and find all the places where that word occurs. Well, some token. Find all my defines. Here we go. There they are. Every occurrence of that string in the entire code base. 860 of them. Well, 859. Yeah, if you play with it and find that you can't make it work for some reason, let me know what the issue is with it. I'm happy to fix it up. Plus, it's going to get better because we have the lister API now, so I'm probably going to actually upgrade it for the next version to send all of that data to the lister API so that you can like narrow in on the file where you want it or find it near some other code on the same line and stuff like this. So Alright, why am I not on the right files here? Okay. So yeah, we were getting ready to do up-down. Man, this is going to be so neat. Once this is in place, I can actually eliminate an old API call for controlling the keys that move you up and down in a list, because you'll just be able to write your own command maps for this shit. I'm actually kind of really liking this being in command maps and not in the coroutine now that I look at it. There might be some good reasons to keep it this way. Okay, so what we need to do is we grab the view. We're going to need this much stuff, and then we're going to do state item index equals state item index minus 1. If the item index becomes less than 0, then set it to option item count minus 1. And then we want to set the view's vertical focus. So for that I have to put that in the state. and then we're going to perform a full update. So there's move up, here's move down. Increment the index by 1, and if it becomes greater than this, set it back to this, and then all that work. So there's move up and move down. Alright, so that's moving up and down, and then there's, what's this right here? Character length. So this is inserting a character, right. So this is the custom command sig list mode write character. Custom doc, a list mode command that inserts a new character to the text field. This is going to mean that people who have been building macro systems that work on recording every command will actually work for lists and stuff now. Like, lots of stuff that it didn't used to work for will start working. It's not a perfect system because if I close the view while it has a state, that won't clear the flag then. But I don't actually need that to be correct, I don't think. I only need it to be correct in the sense that it shouldn't manipulate the text field struct before it's been initialized at least once. Even if it was initialized by a previous view, it won't kill it to run bogus nonsense. It'll be bogus, but it won't crash. It would have crashed if I hadn't done at least that much. Tying like a bunch of different state changes of various natures to the destruction of a view is a really annoying type of thing to have to do. Especially given that you want it to be like a thing that you subscribe to an event. You like subscribe to an event and say, upon this event do this action, and the action is, in this case, look up your state pointer and put a 0 in it, but that's the only way to describe that is with full Turing complete instructions, which means callbacks, which I don't love. And then there's the question of unsubscribing once you've subscribed. Not lovely. Alright, so alright, very good, very good. And now we've done with all of those. We still have these to deal with. So one thing we're going to have to do is create wheel events. I'm not sure if we have wheel events already or not. Yeah, so I'm going to want to add key mouse wheel to this right here, I think. But for now, let's keep plugging forward. We will eventually have a way to subscribe a command on the wheel. That's all we need to say for now. List mode, wheel scroll, custom doc, a list mode command that scrolls the question. No. Yes? No. Yes, why is this a thing? Unclear. I feel like this will eventually just become a wheel scroll command at the global scope, right? Don't you all think? view set scroll, and then we have to update for the switch buffer list. Yeah, the list allocations of type the list all locations of type definition isn't real. It's just an approximation. Even now, that's still the case. It's really just doing a string search for the string, a few strings that might match particular, that might commonly in my code bases define that type. Alright, so that's how we scroll the wheel. Then we're going to have list mode mouse press, a list mode command that begins a click interaction with a list item under the mouse. Uh-oh. Here's where we get into trouble. We don't have access to the control structure anymore. Yeah, that control structure gets freed as soon as we're done laying something out. So the options we have are to lay the whole thing out now and save the control structure, and then use it, then throw it away, and then build it again right after we've updated the state. Or we could query the core for a copy of its copy of the control structure and get that copied back to us. Obviously, if we had a per view arena, then that would have just lived and sat around, but we couldn't keep it because we want to be able to support out of order on a single arena. So maybe we do want multiple arenas, but not multiple coroutines, actually. That could be pretty useful still. to like begin a special mode, push something on, and then end that mode to and pop stuff off in sequence. Actually, I need to think about something real quick. So suppose we have a stack that looks like this. It's like major mode, minor mode, just like this. And the reason I say this is basically this is a special state that indicates that it is dependent on that buffer. Then what could happen is we're in the middle of using buffer mode, and then we begin doing this, it pushes some stuff on, and then we say that we want to switch to list. And so then it can go, okay, well, list at what point does list replace what we have? And it goes, oh, list must replace buffer because list is the first thing here, and like the match between this and that. So to go from that to this, it would then pop everything off and push on his list stuff. And if we wanted to push any other substates like list click, then we would enter list click mode for a little bit and then pop back off of that and then go back to buffer mode, right? Interesting. I'm thinking about how to automatically handle that arena stuff in a way that doesn't force you to like check and see what state it's in and do it, but that automatically gets it right via some rule that can allow different users to cooperate. A lot of times what has to happen is that the core or the helpers that I provide aren't so much about providing a useful API as they are about providing cooperation between things that don't want to stop and think about each other, but who want to act like they own the entire universe. Because if you own the entire universe, it's very easy to write the code that you're trying to write, but that has to be an illusion because you don't own the entire universe. It reminds me a lot of what goes into an operating system, but in a very different way. Anyway, so I guess the right thing for now is to get a copy back. View get UI copy. Okay, cool. That looks good. So then what I can do is just go grab these guys, temp memory temp equals begin temp memory on the scratch, end temp memory on the scratch. On the control, I want to grab view get UI app view scratch. So that'll return to me the control. And then with that, I can ask for this. Right, we're going to want to do user input in equals get command input app. Not sure that'll actually work. Just realized that's not how that works. That only works for the event that triggers you, not the mouse state. Yeah. Okay, so we grab the mouse, and we use the mouse and the view together to get our mouse relative and or view relative and scroll relative mouse coordinates. Then we find out what item we just clicked. Here's the control in question. MYS, MXU, MYU. Could also just make get mouse hit the get mouse hit could be the API layer too, maybe. It's not lovely. Really just want to be able to create that data and keep it around. The fact that two sides of the same API both want the same data is always a pain in the ass. Like, and it's not just a matter of both sides want it, it's that both sides want to keep it past the scope of the current call. In cases like that, it feels like maybe what I should have is some kind of memory sharing section of the API that makes it very easy to create some memory that is allocated inside and controlled by the core, but that is sectioned off from normal core memory so that we can feel comfortable giving the user a direct pointer to it. I don't know. I have to think about this stuff some more. One thing that 4coder doesn't really do is think very carefully about whether or not it passes to the user a pointer to memory that was allocated in the core. And the reason it doesn't think about this is because I've just always avoided doing this. If you want to read memory out of a buffer, for instance, you don't get a pointer to that buffer structure. You pass in a memory buffer and have it fill in the text from the text buffer for you, right? Okay. So I do the click, and then probably going to want a helper for that. List mode get clicked item. Okay. The meow one asks, this is C, right? Yeah, this is pretty much C. I think the only thing that you'll see me do that is actually from the C++ language is overloading functions. I mean, I compile with C++ compilers, right? You see that .cpp? Maybe I need a different color scheme for a sec. .cpp. So I can use C++ features. I just stick to mostly a C style though, yes. Alright, so I get the clicked item, and now with the clicked item, we're just going to go ahead and do get the state off the view. If that state is initialized, we'll do this work. We get the clicked thing, and then finally we set the state's hot buffer ID to the clicked user data, and we're going to cast that to an int32t right there. Okay. So that's mouse press. Here's mouse release. A list mode command that ends a click interaction with a list item under the mouse. Possibly activating it. They're playing some jazzy Mario right now, so I'm a little jazzed up. Ever do any work in Java? Yeah, I did a little. I took one course that was in Java. And made like a little card game like thing in it, and I feel like I did a few other little things here and there that got me into Java a little bit. It's been a long time though. I don't really remember. The only thing I remember is that you call new and you don't call free. That was like my big takeaway that I was able to get used to from learning Java. Buffer ID equals the user data. So what we're doing here is we're saying make sure first of all before we do all this hard work that the state is initialized and that it has a hot buffer ID. Then we're going to do the heavy lifting, which is find the item that we clicked, and then we're going to see if the hot buffer ID that we've stored in the state matches the user data that we got from that clicked item. And if all of that happens, then we activate the item. I really like managing memory. I wouldn't have it any other way. Okay, so there's click and release. So I think the next thing to do would be, I don't know, mouse move. Alright, so that's some pretty good progress. Gonna need another 5-minute break, so I'll probably shut the stream down while I'm away to let the computer cool off again. But because I can hear the fan still, basically. But the next thing we need to do is we've got all the commands written. We need to build the command map, the default lister UI map, and then we need to deal with a couple of problems where it's not possible right now to bind some of these commands to the events because I never fully made the mouse events possible to detect and bind to mappings, right? And I also want some way to think about when I'm binding the maps how I deal with the fact that sometimes I will get multiple mouse events, like the mouse couldn't move and wheel scroll at the same time. I don't need all of those events. I just really need the wheel scroll one. And so I want some way to, in the mapping, when I'm binding things, there might be like a mouse move raw and a mouse move and no other mouse event that you can bind to, depending on which kind of event you care about. So yeah, we'll take a look at all of that stuff in the in the next stream. I said 5 minutes, but actually it might just be later tonight. Late. I feel like getting a lot done today, so I will get this done at some point, but 5 minutes is probably not accurate. I probably won't come right back. But yeah, thanks for hanging out, folks. I will be back in 5 minutes or a long time